Hey there! If you're a B-Tech student deep in Java, you've probably spent a lot of time staring at a console window. But what if you want to build actual clickable apps? With windows, buttons, all that good stuff? Well, that's where GUIs, or graphical user interfaces, come into play. Today, we're going to dive into how to build them using a really powerful Java toolkit called Swing.
So here's the plan. We'll start with a little history, figure out why Java's first GUI toolkit didn't quite cut it. Then, we'll pop the hood and look at the smart design that makes Swing so powerful. After that, it's time to check out the tools of the trade, all the bits and pieces you can use. And finally, we'll put it all together and build our very first app. Let's get into it.
All right, first up, to really get why Swing is such a big deal, we need to rewind a bit. Let's go back to the early days of Java and meet its first GUI toolkit, the Abstract Window Toolkit, or AWT for short.
Have you ever opened an old program and it just felt off? Like the buttons looked weird or the windows didn't quite match the rest of your system? That wasn't just a quirky design choice. It was actually a huge technical problem. And it all comes back to how AWT was designed from the ground up.
Okay, this slide breaks down the core difference. AWT components were called heavyweight. Just think of them as Java telling your operating system, hey Windows, draw me a button. So on Windows, it looked like a Windows button. On a Mac, it looked like a Mac button. Sounds good, but it was a nightmare for consistency. Swing flipped the script with lightweight components. These are 100% pure Java. Java itself draws the button, the text field, everything. And the result? Your app looks and acts the same no matter where it's running. That's a game changer.
So really, the jump from AWT to Swing was massive. It was like swapping out a rusty old toolset for a brand new high-tech one. It finally solved that write once, run anywhere promise for GUIs and gave developers way more power and flexibility. But the cool thing about Swing isn't just how it looks. The real magic is actually in its architecture, its internal design. And this brings us to a concept that's absolutely critical in software development today, the Model View Controller Pattern, or MVC.
Now, don't let the name intimidate you. MVC is just a brilliant way to organize your code so it doesn't turn into spaghetti. It splits your app into 3 separate jobs. You've got the model, which is all about the data, the view, which is what the user actually sees, and the controller, which handles all the user's clicks and typing and tells the other two what to do.
Here's a simple way to think about it. Imagine you're at a restaurant. The model is the kitchen. It has all the data, the ingredients, and the logic for how to cook. The view is the menu and the plate of food you get. It's just the presentation. And the controller? That's the waiter. The waiter takes your input, your order, and relays it to the kitchen. It's the go-between. Keeping these 3 separate is the secret sauce to clean code.
So why should you care about this? Simple, because it saves you from massive headaches later. Without MVC, your code for the user interface, the data, and the logic all gets tangled together. With MVC, if you want to change how something looks, you just touch the view. Need to update your data logic? You only work in the model. It makes everything so much cleaner and easier to manage, especially as your projects get bigger.
Okay, that's enough theory. We know the history, we know the architecture. Now for the fun part. Let's actually open up the Swing toolkit and look at the pieces you'll be using to build stuff. First up, we have components. These are basically the Lego bricks of your user interface. You've got your classic J button for clicking, a J text field to let users type in text, J checkbox and J radio button for options, and J label for just displaying some static text or an image. Pretty straightforward stuff.
But you can't just have a bunch of buttons floating in space, right? You need something to hold them. That's where containers come in. The main window of your app is a J-frame. Think of it as the main box. Inside that box, you can use J-panels to organize things, like grouping all your login fields together. And for those little pop-up alerts, you've got the J-dialog.
So, we have our components and we have containers to put them in. But how do we position them? Well, you could calculate every single X and Y coordinate, but trust me, that's a terrible idea. The second someone resizes the window, everything breaks. The smart way is to use a layout manager. You just tell the container how you want things arranged. Flow layout puts things in a row. Border layout gives you 5 distinct areas. Grid layout makes a perfect grid. The layout manager does all the heavy lifting of positioning and resizing for you. It's an absolute lifesaver.
All right, that's it for the theory. We've covered the history, the architecture, and all the individual parts. It's finally time to see how it all clicks together in some actual code. Check this out. It really is this simple. Let's just walk through it real quick. First, we create a J-frame and give it a title. That's our main window. Next, we make a JLabel with our hello message. Then, this is the magic part, frame.addLabel. We're literally adding our text component to our window container. The last few lines are just cleanup, setting the size, making sure the X button actually closes the app, and then the most important line, frame.visibleTrue. If you forget that one, your app will run, but you won't see a thing.
And those few lines of code we just saw? This is the result. A real window pops up on your screen with a title, with our text inside, and with a close button that actually works. That's it. That's the core idea of Swing, combining components and containers to build a UI. And just like that, you've built your first GUI app.
So, let's recap. Swing is this awesome platform-independent toolkit for building UIs in Java. It's built on a smart MVC design, and it gives you a whole box of components and containers to play with. You now know the fundamentals to go from a totally blank screen to a working window. So, the only question left is, what are you going to build with it?